So this is actually going to be carbon number 2. You want to have as low a number as possible. So if the methyl group is on that one, then that becomes carbon number 1. And then if the methyl group is on that, it would be 2-methylpentane. So a methyl group on there or on there would give you the same name. Okay? What if the methyl group were on the end carbon? Would you call that 1-methylpentane? No, that actually adds to the length of the parent chain. If this wasn't there, but it were here, now that would only be 2 hydrogens on that carbon. But that actually would make a 6-membered parent chain. That would be a hexane now. Okay? So if you're adding a methyl group to the end carbon, you're actually adding to the parent. And that would be hexane. So just be careful of that. What is the chemical formula? Okay, this should be obvious. Miss BQ, how do I erase out here?
With your palm. Do this.
Huh? What if I'm sick? I don't want to make you sick.
Well, I said it's a pain in the butt because I often have crap all over my hands, ink, marker.
Yeah, you know, mark up the TV.
I know.
Well, didn't think of that
They
either.
said we didn't really think about that.
Okay, all right. All right, well, that's good. I'll try not to sneeze into my hands.
Thanks.
What was I going to? Oh, the chemical formula for this. Let's count up the number of atoms. 1, 2, 3, 4, 5, 6 carbons. Yeah? C6. And then H's. We have 3 plus 2 is 5, plus 1 is 6, plus the 3 there is 9, plus 2 is 11, plus 3 is 14. 14 H's. What does that look like? C6H14. Yes! If we go back to this, oops, went too far. Hexane, C6H14. So and hexane we know is just 6 carbons in a row, but that's not what that is. That's not hexane, that's 3-methylpentane. It's got the same number of carbons and hydrogens, just a different arrangement of the atoms. So this gives rise to this term that I mentioned earlier in the hour. That's what our reading quiz is about, structural isomer. This compound winds up being a structural isomer of hexane. You get an isomer when you have a different compound, yet it has the same chemical formula. Same formula, different arrangement of the atoms. Questions about that? So this is not the same thing as hexane. It's not the same thing as pentane. It is its own compound with its own properties that would be different from pentane or hexane. Yes?
I just want to double check, but you said that the order of the CH2, CH2, like it goes backwards. Right? So like if it was on this CH2.
If it were on that one,
Uh-huh.
yes, that would be carbon number 1 in the parent, and it would be called 2-methylpentane.
Okay.
So it is possible for the numbering to go backwards.
I mean, I'm just wondering if it was CH2 on the one on the right side of CH, that would be CH2 or CH4?
You're talking about if the CH3 were on that one?
Yeah, like would it be 3-methylpentane or would it be like 2 or 4?
It would be.
What would you call it?
It would be 2. Oh man, my letters are running together. This carbon would have an extra hydrogen on it because every carbon needs to have 4 bonds on it. So yeah, that one, which only has 1 there, is going to have 2 there. And then this one would go down by 1 hydrogen so that it can attach to the methyl group. What's the name of this thing? It would be 2-methylpentane. Yeah, that would be carbon number 1. Just like if that methyl group were on that carbon, it would still be called 2-methylpentane. All you gotta do is turn that molecule around, it's the same thing. Okay, we're just looking at it from the other side pretty much. It's the same molecule. So we'll always just use that system for numbering, to try to keep the numbers as low as possible. And we'll see some examples. In fact, I think coming up very soon, we'll do a few examples of how you number those things.
Yeah, so where's the number?
You always number the carbons in the parent, and you do that to identify where the functional group is. This is our functional group, so the parent carbons are 1, 2, 3, 4, and 5. We don't care about 1, 3, 4, and 5 because they don't have anything on it. But number 2 does, so we call it 2-methylpentane. All right? We'll do a few examples after this. This is just a few guidelines as to how we'll name organic molecules. The N carbon on the parent is closest to the functional group is number 1. So that second bullet point up there, there's more than one functional group alphabetized. If there is a long parent and there's a methyl group somewhere on it and an ethyl group on this someplace, then you'll still have to number them the same way. Number so that on the parent, so that you have the smallest possible functional group locations. But you'll always put the ethyl first before the methyl because alphabetically it comes first. Now, I will be honest with you. I'm not going to mark you wrong. If you put the methyl first and then the ethyl, as long as you identified where they are in the right place, it's fine. This is the proper systematic way for it. But that is a pretty minor detail, and if you can identify where they are, I'm good. Yeah?
Can you show an example? With,
Yeah, I'll show you what I mean. There's the next slide's got some examples. Yep. And we haven't really talked about naming the alkenes or alkynes yet. That's where we have the double and triple bonds. So I'll get to that. This next set of examples does not have any of those yet. I'll show you what I mean when I get to that part too. Okay. So let's go ahead and take a look at this. And this will hopefully shed some light on how this works. So this one, let's just do this one together. It's very simple. There's a long carbon chain with one functional group on it. It shouldn't be too hard to name. What would be the name of the parent? You just count how many carbons in a row there are. It's an octane. So this name is going to end with octane. And we see there's one functional group on it, and it's right there. Okay, so we have to decide. Where is this functional group? Is that going to be carbon number 1 on the left side? Or is that going to be carbon number 1 on the right side? Yes, it's going to be on the left because if we start over here, this chlorine is on carbon number 4.
Oh, I see.
If we start over here, the chlorine's on carbon number 5, right? So that's how we know which one which carbon on which end goes as number 1. So this is 4, and the Cl is, we just call that a functional group called the chloro functional group. It's 4-chloro, and then the parent is octane. And this is kind of funny too. You're not supposed to put a space in between where the functional group is and what the parent's name is. So we would call this 4-chlorooctane. If somebody came along to read this, they'd say, "Oh, this is 4-chloructane because it's two." No, but we know better. We know what the name of the parent is. It's octane. So you just have to. We know how to say it. Okay. Anybody have any questions on that one? That was pretty simple. Let's go to another one. There's more functional groups on this one. I'll give you a second on this one. What is the parent in that one? If you said heptane, that's wrong. It's a be careful example. Be careful. The parent is the longest continuous chain of carbons.
Oh.
And so our brain starts to get conditioned. Oh, I'm looking for that long horizontal chain. Whoops. You see what I'm saying? So here's my parent chain. And when I get there, I could finish it there, but notice we got the carbon there and there. That adds 2 more carbons on the end. I've just scribbled through the parent. Yeah, so it's an octane. So be careful. Yes?
I'm confused. I don't understand. Like, how did you get octane?
Okay, so are you okay with the idea that the parent is the longest continuous chain of carbons? Okay, so 1, 2, 3, 4, 5, 6, 7, 8 carbons all are continuous.
But why aren't you counting the ones in C?
Then this one, and this one would all be considered functional groups on that parent. So there's 3 methyl groups on the parent. That's how we think about it. Yeah? Identify the parent first, and then anything else in there is, and that's why I think it helps. I always like to just, if I'm having to name one, I'll scribble through the parent, and then everything I haven't scribbled through is going to have to be named in a functional group, or as a functional group. Okay, so if we identify the parent as an octane, can we finish the job here and identify those? Is the carbon on the left carbon number 1 in the parent, or the one on the right? Yeah, that one is going to be carbon number 1, so that the numbers of where the functional groups are as low as possible. You always want the lowest combination of numbers for your functional groups. The name? Who's got it? Anybody want to try this thing? Come on. Okay, Nathan, right? Nathan.
3,4,5-trimethyl-octane.
You got it. 3, 4, 5. You got a methyl group on carbon number 3, one on carbon number 4, and one on carbon number 5. Nice job. 3, 4, 5. Trimethyl. It does say on the previous slide, if you have more than one of the identical functional group, you use di or tri or whatever you need. You could use tetra if you have that many. Trimethyl octane is an octane.
Are we looking for commas in between the 3, 4, 5?
Yes. Maybe there's an eraser. Oh, look at that. Oh, man. So my 4's got a extended